Welcome to qnawire.
So we can say that the acceleration is found in example 1019 to be a constant value, a equaling 2/3 of g. Again, this is from example 1019. Therefore, constant acceleration kinematics can be used. We're going to say downwards is positive. And so we can say Vy squared would equal Vy final squared equals Vy initial squared plus 2 times acceleration in the y direction times delta y. We know that the initial velocity is going to be 0. Therefore, the Vy final would be equal to the square root of 2 times the acceleration in the y direction times the change in displacement in the y direction. So Vy final would be equal to the square root of 2 times 2/3 g times h, the height. And this would be equal to the square root of 4/3 g h equaling v final. So this would be our answer for part A. For part B, however, we're going to take the zero level for gravitational potential energy to be the starting height of the yo-yo. So we can say that due to the law of conservation of energy, E initial equals E final. We can say that then 0 equals U final plus K final. And we can say that 0 equals negative mgh plus 1/2 times the mass times the velocity of the center of mass squared plus 1/2 times the moment of inertia of the yo-yo times omega times the center of mass squared. So we can say mgh equals 1/2 times the mass times the velocity of the center of mass squared plus 1/2 times the moment of inertia of the yo-yo, so 1/2 mr squared multiplied by the velocity of the center of mass divided by r squared. Because the yo-yo is rolling without slipping, we can make this assumption. If the yo-yo was slipping, we cannot make this assumption. And then at this point, we are simply going to solve for the velocity of the center of mass. So the velocity of the center of mass would then be equal to the square root of 4/3 gh. This would be our final answer. That is the end of the solution. Thank you for watching.